We are moving to even a more advanced topic. So I hope you also pay attention, and if you have any question, let me know. Yeah. Using scanf and sprintf? No, it doesn't work like this. Maybe what you need to specify if you want to do exactly this is don't pass the full string. Basically scanf and sprintf operates the same way exactly as you deal with the screen. So it scans the screen from the beginning, looking for a certain character that matches, right? So it will do the same thing. If you want to read a certain character from this one, you either don't use sprintf or scanf, which is actually the easier solution. Or if you specifically want to use this, is you pass the input string such that it starts with the letter that you're looking for. Right? So you do it yourself, you scan it, you stop, you basically define another array that starts with the letter that you want to actually take and put in the other variable. Right? But by this, sprintf and scanf has actually no useful use case in the example that you mentioned. Okay. Okay. So pointers. Okay. So this topic is confusing for so many, but actually it's an easy one if you pay attention to the way it works or understand what happens behind the scene. Don't just focus on programming. So what happens behind the scene, we mentioned before, is basically each variable has a place in memory, and this place has a specific address, right? You remember we discussed this? So when you define any variable, what you do, assume I define int x. What the program is going to do is go to the memory. This is int, so it's 4 bytes. So because the memory is byte addressable, so it takes 4 memory locations, 0, 1, 2, 3, 4. And then this will hold the value of x, starting from address 0. This is the address here, right? Sometimes you need the value of x, but some other times you need the address of x. Can you give me an example that we covered so far that we need the address of x? Yeah. But if you read from the user, you just take the value, right? You don't take the address, yeah. If you pass this variable to a function that you want to change, right? We said you cannot have multiple return values from a function. What if I want to change 2 things in a function? We said a solution for this is to pass these 2 parameters to the function as an input, but pass them by reference. And we mentioned that passing by reference is sending the address of the variable rather than sending the value, right? And we had an example of a and b and x and y. Good? So this is one example of you need the address of x to pass it to a function that will later modify this memory location. Good? Okay. This is what is stated here. And to deal with this, we had the AND operator. I told you before, this is the way you pass things by reference, and basically it means the address of this variable. So one example here is, this is my main. I define a variable n equal to the value of 6. Then I do print 2 things. I print the memory location for this n is at address. I'll tell you what is this right now. But here, and n is the address of n, not the value. So and n is not 6, right? And n is the place in memory that this 6 is stored. So it's a memory address. The value of n is this thing. And we had this before, and basically you print n. So it will be an integer value, which is 6. So we know that the second line will give us 6. But the first line will give us where the 6 is located in the memory. So if you try this out, you will see something like this. So the memory location for n is at address this. 0x, you know what is this? You know hexadecimal values, right? From digital logic design course. Do you guys know what is binary and hexadecimal or no? Yeah. So this is just a value, right? A number, but it's represented in hexadecimal representation. And this is how we deal with addresses in computers. like you have a memory that is 4 gigabytes. It starts from address 0 up to 4 gigabytes is actually 2 to the power 22. You go to the address 2 to the power 22, but because it's a very big number, we represent this as hexadecimal. Right? So 0x here means hexadecimal, and this is the value. Good. So what you see here is the address of n. How did I get that? You did this by using the AND operator, which gives you the address, but also you want to print this in a hexadecimal format, and this is the specifier of like %b. This is how you print a pointer to the screen in a hexadecimal representation. Right? Do you have any question here? So conceptually, a pointer is another variable that stores the address of the variable that you are talking about. So you have n and you have the address of n. These are two different things. N is the value itself, but the address of n is a pointer to the location of the memory where the value is stored. Okay. So because n is an integer, so it has 4 memory locations. Which one of this is the address of n? It's the starting address. Because I told you in the previous example here, it went away, but basically an integer is 4 bytes, and memory is, every location holds only 1 byte. So what is printed here is only the address of the first byte. And then the remaining ones are just +1. So this is the address that we have here. N starts from here, and then you put it here, you put it here, you put it here. Right? Good. So it makes sense that you cannot apply the address operator to a constant. The reason is, this is from the very, very first lecture. Why I cannot apply the address operator to a constant? Yeah? The constant is not even stored in memory. You don't have an address to that one. So what does it and mean? And deals with an address and a memory. Constant is just a constant. It's not stored in the memory. Right? This is why you cannot use that or even that. Good. I already discussed this with you when we talked about arrays. I told you that the name of the array, if you define an array int a array, what does a represent? It represents a pointer to the first index or element in the array, right? So I told you arrays are contiguous places in memory that starts with a certain address, and then you keep increasing with this address, right? If it's an array of integers, then the first element is a certain address, and then +4, +4, +4, because each entry of integer takes 4 bytes, right? So if you define such array, and you guys, you have your laptops, you can actually try these things while I'm talking. It's good to see things yourself. So basically, the memory location for B0, which is the first element, is, and I'm here printing the address of the first element, the second element, third element. What you can see is a certain address, which is for B0. By the way, this doesn't have to be the same thing that you see. Can you imagine why? You may get a different number, even if you actually run the same application on your laptop. Why maybe you get here a different number? Yeah? Yeah, it will be allocated to whatever place you have empty in your memory. So when you run things are running in the background in your laptop. You have the operating system, other applications running. So when you run this specific one, it gets placed in a certain place in memory. What is this place? It depends on what is empty. Sometimes it's the beginning of this address, sometimes a completely different address, right? So it's okay to have different results here. But the thing that will be fixed is the difference between these two will be always 4. Why? Because we know that B0 or the array itself is integer. That means, and it's contiguous in memory. So whatever address you start with, this is +4, +4. And you can try this yourself. Is there any question?
If you copy the address for just B without index, would that give you anything? Would that mean?
If you?
So if B is an array and you didn't index a point.
B0, for example.
Yeah, if you just did B, 2 square brackets, would that give you anything? Or would that
Without the and thing?
Yeah, without anything between brackets.
No, right? You cannot, even this is not a valid syntax in C, right? Maybe you just write B, not B with brackets. And we will see this now. So B is just the name of the array, which I told you it's also a pointer to the first element. And we have an example on that. Thank you. Okay. So this was related to what you said, is actually the name of the array is a pointer to the first element. So if we try this, if this is what you were looking for. So here I try to bring two things. The address of the first element and the address somehow that is B. What is B is the name of the array. I told you that the name of the array is a pointer to the first element. You can verify whether what I said is correct or not by doing this. Okay, I'm telling you that the name is a pointer to the first element. So let's print the address of the first element and the value of this B. If they match, that means that's correct. B is actually a pointer to the first element. If they don't match, then what I'm saying is wrong, right? This makes sense? So if you print these two, you have to get exactly the same result. The reason is B, the array itself, is the address of the first element of the array. Good? We explained this when we discussed arrays in members. Good? Okay. Is there any question? Good. So we also discussed this. We said, as a compiler, as a C compiler, how would I know if you define such an array and then you access element 2, B2, or B1, or B4, or B5? How would I know which memory location it is? Can someone explain to me? Someone from the back. If I define an array B, and then I want to access B5, as a compiler, how would I interpret this B5? The same faces every time? Other people? Yeah? Yeah, first, B gives you the first element, right? And then you set 20 because I said the fifth element, which is, it's an integer, so it's 5 by 4. So it adds 20 to this address, right? So this is exactly, thank you. Please give me your name afterwards, okay? So what your friend here is saying is basically I have B. B is a pointer to the first element. I want to access B5, which is here. 0, 1, 2, 0, 1, 2, 3, 4, 5. This is 5. How would I get this address? You already have this. You know each entry here is 4 bytes, so you multiply 4 by 5, which is your index, and then you go to this address. And I gave you an example about this before. Good? One problem is C, for the third time I mentioned this, has no boundary checking. What it means is if you actually try to access B minus 2 or B 200 or anything that is outside your boundary of the array, it will not complain. That doesn't mean your code is correct. It means actually it's very risky. Why it's very risky? Because now you are accessing a place in the memory using the same math that we have here, but it's not part of your array. So it can be part of anything else. It can be an address of another variable, or it can be an address to a variable in a completely different program. It can be anything. So your program can crash, other programs can crash. Your operating systems, hopefully not, because you are not within an authenticated region, but may crash, and actually this has a security implication. Some people use this to access certain memory addresses that has authentication bits for the operating system. So it has a security application here, but if you don't intend to harm your computer, then you shouldn't be doing this. You have to make sure that you are within the boundary of your defined array. Otherwise, you are accessing a base in the memory that you don't know what is it. If you read it, then that's okay. Maybe your program has a wrong value. But if you write into it, this is the risky thing. Right? All of this is writing thing. Here, how do we define a pointer? We have been talking about pointers a lot. How do we define a pointer? So the way you define a pointer is to use this asterisk character with the type. So int, this asterisk means you are defining a pointer to an integer variable. So what is in front of the pointer definition is not the type of the pointer. It's the type of the variable that the pointer is pointing to. And this is what confuses people. So if this is the type of the variable of the pointer that it's pointing to, then what is the type of the pointer? Do I need a type for the pointer? Yeah, but why? This is what I'm like. What is the logic behind it? Why a pointer is a type of itself? Can't a pointer be like double or character or string or int or anything? Yeah? Yeah, you cannot have a decimal address to a memory. You cannot have an address in a memory that is 1.5. And you cannot have address in the memory that is hello world, right? It cannot be a string or double or anything. It has to be actually an integer value, right? Right? So a pointer is a type that by nature holds only address, like value of addresses. And an address is actually a positive integer value. It cannot be negative. It cannot be a double. It cannot be string. Right? So a pointer is a type of its own. But what you write here is not the type of the pointer. The address can point to anything, right? It can point to any data type because you can place in the memory any data type. And this is what defines what the pointer is pointing to. If you have any question, let me know. If you are confused completely, also let me know. Okay. So we'll have some examples. So I guess if you are still not very sure, let's see. So here I'm defining an end pointer that I call end pointer. This is a pointer to an integer variable, right? So, and if you place the asterisk here or here, it doesn't really matter. It's exactly the same thing. This is a pointer to a character, right? So let's see if I have a pointer to an integer variable. This is the pointer itself. But remember, the pointer, which I called end pointer here, is also a variable, right? So it has a place in the memory, that it has an address to it, right? Do you see that? So let's look into the example. So here I define two things. An integer variable, this is very easy. A place in the memory has a value of 8 and it has this address. Good? We have seen this before. End pointer, this is the problematic thing. The only thing you need to understand is pointer is nothing other than a variable. So again, it's exactly the same thing as this one. It has a place in memory, it has a certain value, and it has an address, right? The only different thing about pointers is what is this value? It's also an address, right? So this one, if you assign the address of n to n pointer, it will basically take this address here, right? It will copy the address of n and put it in the value of n pointer. As you can see, this is a thing and this is a completely different thing. This is an address to a variable, but this is the address of the pointer itself. And this can mean that I can have a pointer to a pointer, right? This makes sense? Because a pointer is nothing other than a variable that has an address. This address I can point to by anything else, right? It's getting confusing more and more. Yeah? So let's see some more examples. So if you want to imagine this thing, as if I'm saying by assigning the address of n to n pointer, I'm saying the value here is actually pointing to this memory location, right? Good. So this is what we have done. Now I'm initializing, I'm changing the value of the n pointer to 20. And this in C has kind of complex name that is called indirection or dereferencing. And basically, it just changed the value. So how would I explain this? Okay. So now I have, this is my memory. I have n here. I have n pointer pointing to this one. Assume, forget about these things for now. Assume this address was 5. That means n pointer has a value of 5. Later, I change it 5, which this is, what is this line about? I change it 5 to 20. But Because I'm not changing n pointer itself, I'm changing this thing. You remember when we said this AND is your address operator? On the other hand, your asterisk is the value operator. What it means is when you use this asterisk in front of the pointer name, you are not referring to the pointer. You are referring to the value that the pointer is pointing to. What the hell? So you have x variable, you want to pass the address of x to a function. We use AND x. We said AND x will pass the address of x, right? When we come to pointers, asterisk does completely the opposite thing. Asterisk is used with a pointer, but not to access the pointer value, which is the address, to address the value of that pointer, which is here n. So when I say n pointer is 20, I'm not changing the address. I'm actually changing the value that this pointer is pointing to. If n was originally 8, I'm changing this to be 20. Make sense?
So basically, like, it places 5 with 20 or 8 with 20 in that same jar. Like, if we think of the address to be like a jar.
Yeah. If this memory location is a jar and the pointer is pointing to it, it replaces what is inside the jar. Yeah. Okay. Yeah.
So just to confirm, so this is not changing the memory address of AND, it's just changing the value.
Yeah.
How would you change the memory address?
How would you change the memory address? We will see how to assign. One example would be, maybe I'll ask the question in a different way. How would I change the value of a pointer? Right? So originally, this pointer had no value. But then I changed it by assigning it to an address. Right? So what is this address? Is basically making pointer pointing to a certain memory location. You cannot change the address of this variable because it's already assigned by the hardware. But what you can change is what n pointer is pointing to. For example, you can have another variable here that is m. You can assign n pointer to m instead of m. Okay? Okay. So here is another example of using pointers. Ask as many questions as you would like. Right? Because this is actually a complex topic. I don't mind spending even the next lecture on the same topic. Right? So if you have many, like whatever question you have, please ask. Yeah.
Can we change variables together by having their addresses equally? So can you change the address of a variable?
Yeah, this is exactly his question. You cannot do this. And the reason is they are already placed by the hardware. That's why it's important to understand what is the logic behind pointers. Right? Actually, even in C, you cannot assign a fixed address to a pointer. There are indirect ways of doing this. But you cannot say, I want my pointer to be 0x453. Right? And because this 453 may not be within the area that is allocated to your program. If you know what are the limits in the memory that is allocated to your program, you can do this. But maybe 0123 is in an operating system region. Right? It's like an advanced topic. Like to answer your question, no, you cannot change the address of a variable. Okay, so here is another example. Don't ask each other. I mean, you can ask each other after the lecture. That's okay. But I'm here to be beneficial to you. So maybe you just ask me. Yeah.
Would you be allowed to, if you were to define A and B first, could you then assign the pointer to the address of B all in one line? Like,
So you define A and B, and then you want to assign. Oh, so you say if I. That's an very interesting question. So what you are saying, if I define everything in one line, int A, B, and B pointer, for example, or maybe just what I have done here, but I want to assign B pointer on the same line as A and B. What you're saying?
Well, no, assign assign A and B first, and then the next line do int star B pointer equals at B.
Yeah, initializing the pointer when defining it, right? You can do this. You can, because again, it's a variable, and we have rules in C to initialize a variable, which you can do on the same line that you define it. So you can do this. And this is very similar to do this. We are initializing my pointer, but just to a null. Right? You can replace the null with and B after you define B. So the example here, I defined an integer pointer. Initially it's null, so it has no it has no value, it's just 0. And then I define two variables a and b, 25. I make the pointer is pointing to the b location by assigning it the address of b. And then later I'm saying a has the value of the variable that b pointer is pointing to. As you can see, this is completely equivalent to say what? A equal b, because b pointer is pointing to b. Later, I am dereferencing b pointer by just saying it's the value of b is 0. Right? So, in the first line, null means address of zeros. Yeah. It here, making it as a null. Here? First line, okay. Yeah, because this is a pointer, right? Okay. That's also important to mention. The asterisk has two uses. Defining a pointer and the dereferencing thing. When you define, so when it has a type in front of it, it's not dereferencing, it's defining a pointer. Right? So this is just telling, if we don't have this, that means b pointer is just an integer variable, right? It's what we had before. But by doing the asterisk here means this b pointer has to be a pointer to an integer, right? When dereferencing happens, when an asterisk means dereferencing, when you find it in an assignment expression, you assign something into it. Yeah. No, because we said asterisk here means the value that the pointer is pointing to. So remember when I said and means the address and asterisk means the value? This is how we should consider it. So asterisk pointer means the value that the pointer is pointing to, right? Which is b. That's an interesting thing. So null is not a valid memory location. Null is not a memory location. This is why it's safe to initialize it with null. Say it points to nothing now, just to be in the safe side. This is a good programming practice. If you define a pointer as null, you say I'm not pointing to anything, because if by mistake you change it like it's the value that is pointing to, you are safe. You are not changing any place in the memory. So it's a good practice when you define a pointer to initialize it with null. Yeah.
It's not necessary to initialize it with null.
Yeah, it's not necessarily. This is what I'm saying. But it's good practice. Like, did you infer from what I said? It's like it's a must. It will not give you an error or something, right? But it's safe. It's safer to initialize it to null. And actually, some compilers would by default do this, even if you didn't initialize it. But what I'm saying is, like, to be completely safe across all platforms and compilers, just do it yourself. Thanks.
So if you like in A right now, you get a value of.
Yeah, I'll discuss this. I'll discuss this. Who stores the address of a pointer? Right now, we don't point into this by anything, but you can define another pointer that points into it, right? I don't know if this is clear, right? You can ask the same question before we cover pointers. Guys, I'm okay to answer any question, but I'm not okay that you keep talking, because... Okay, so this question is very important. It's saying what stores the value of, what stores the address of the pointer itself. If we didn't cover pointers, like if you come to me before this lecture, and you ask me what stores the address of the integer variables int x, we didn't use it, but the address is in the memory itself, right? But we didn't point into it. So, and pointer is just a normal variable that has an address. If you need to use it, you define another pointer that points into it. And we will have more examples later. Linked lists and these kind of things. But if you don't use it, then you don't need to store it anywhere. The memory already knows where pointer is located, right? So the hardware has this knowledge. What pointer does is not store the address. It just provides you an access to this address, right? You basically copy the address into a certain variable. So let's go through the example and make sure you understand what is going on. So I define a pointer, initialize it to null. This is why it has this value here. I define two variables, A and B. I initialize B to 25, but A has no value here. And then in the line 3, I assign the pointer to the address of B. So it takes this address. This is the address of B, right? And then in the fourth line, I say A has the value that the pointer is pointing to. What the compiler is doing is, and please focus on this. In line 4, what the compiler is going to do to execute this line, go to this pointer, take the address, go where in the memory this address is pointing to, takes 25, copy it to A. These are the 4 steps that will happen when you do dereferencing in C. Take the address of the pointer, go to the memory, copy the value that this address is pointing to, and place this in the variable that you are assigning the value to. So here, take this address, go to here, it's B, copy 25 into A. Good? And then finally, you say the value that the B pointer is pointing to should be 0. What will happen is you will copy this address, go to the memory, and replace it with 0. A will remain 25. Why? Because pointer is not pointing to A. Pointer is pointing only to B. Right? And there was a question right here. I guess this answers the question. Do you have any question? So you can assign an address of a variable to a pointer. We have done this. You can assign a null to a pointer to point to nothing. We have done this. You can also assign a pointer to a pointer. And the reason is they have the same, but it has to be of the same type. So if it's a pointer to an integer, and then you have another pointer to an integer, you can assign pointer A to B, right? What will happen in this case? Both pointers will be pointing to the same memory location, right? So here, I say pointer 1 is null, pointer 2 is null, and then I define later, and I define another integer variable n. And then I assign the address of n to pointer 1. This will happen. Then later, I say pointer 2 is equal to pointer 1. So both will point to n, right? Clear? This makes sense? Do you have any question? Okay. So later, if I say pointer 2 equal, like the dereferencing thing, the value that the pointer 2 is pointing to should be 76, then n will be 76. Right? What if I do this later? Int m equal n pointer 1. What should be the value of m? 76, because pointer 1 has the same address as pointer 2. You change it this, so pointer 1 is pointing to 76. It will take the value, place this in m. Right? Yeah?
What's the point of having two?
That's a good question. What is the point? So first of all, we are just discussing what can we do. We didn't say use case, right? But his question is, what is the point of having two pointers pointing to the same place? Good. Assume, and this is later in linked lists. But assume you don't know what is linked list, right? You have one memory location, and then you have one pointer pointing into it. You want to keep the address of this variable, but on the same time, you want to do a math operation on the pointer that it's pointing to. Then what you need to do, define another pointer to this variable, and then change the original pointer, right? So right now, it's not a valid use case. It does nothing because pointer 1 is not changing. But later in the program, if you change pointer 1,